A good prototype is not the one that looks the most beautiful or is the most well made. It's the one that answers questions and moves you forward. Often, these are the ones that don't work and are a complete disaster as much as the ones that work brilliantly. It's easy to convince yourself when a prototype doesn't work that you've failed, and even now when they don't work I find it frustrating, but I also love this phase because of the challenge and because every prototype I make contains clues that help me to see and fix problems and suggest lots of improvements so that my next prototype will hopefully be a few steps closer to a successful design. I've made a lot of prototypes and models. People use different terminology, but for me, models are visual. They may be scaled down, but generally they describe the design's visual appearance, but they don't function. Prototypes show how your design works. They may not look anything like the final design, but they demonstrate how it would function. When you get a combination of the two, I would still call it a prototype, but it's like the difference between product design and industrial design. It's just not worth getting hung up on. You have to choose the right type of model or prototype for where you are in the design process and what questions you need to answer. So, depending on the design brief, you may just need a model, you may only need prototypes, but usually for each project you will have to make both. In a typical project, prototypes come before models because form often follows function. There's no point in working out the outside shape and look of something until you know how big an internal space needs to be for a circuit board or a mechanism to work. Of course this depends on the product. If you are designing a potato peeler handle, for example, the form is the function, so the prototype could also be the visual appearance model. Look at this pair of pliers. On paper it looks good, but sketching and CAD can only tell you so much. Now there are lots of examples of pliers already in production and we all know how they work. It's not complicated. So with time pressures, the temptation could be to just make a quick visual appearance model, or worse, progress straight into manufacture. But a working prototype tells me how it behaves in use, and it turns out that when you close the handles together, they pinch the palm of your hand, which is really painful. You can probably imagine the trouble caused if you'd pushed on to production with only a visual appearance model that didn't open and close. The customer complaints, the money and time lost to correct the tooling, the product recalls, it would be a nightmare. I learnt this the hard way. You have to make prototypes to test the feasibility of your ideas, to highlight problems, to use in focus groups for feedback, and to refine your designs. You're not designing for yourself, you're designing for others, so you have to give your prototypes to people to test. Put them in big hands and small hands, young, old. Find a range of people to identify problems. Prototyping can be a specialist area of design. It can take more thought and effort to work out how to design the prototype to prove your idea than the actual design itself. This prototype for a pepper grinder looks nothing like the finished design because it's just designed to test the mechanism. But by putting in a lot of thought at this stage, I can design and build the prototype to accommodate several experiments, rather than having to build a new prototype each time I want to test something else. So with this prototype, I can swap shapes in and out to test numerous angles and grating ideas, and I can watch what's happening through a viewing window. Prototypes are experiments. In science, you come up with a theory, you design an experiment, you test your theory, analyse the results, and come up with ways to improve the experiment, and prototyping is no different. James Dyson said he had to make 5,127 prototypes to get his first bagless vacuum cleaner right, but it was worth it. So as the pliers example shows, depending on the project, it's often important to make a combination of visual appearance model and working prototype to get as close to the finished design as possible. This is why today rapid prototyping is so useful, because of how accurately you can create designs from the data that will eventually go for manufacture. This process is much more streamlined, but rapid prototyping is not always cost effective or practical to use. Most companies only have access to machines with relatively small bed sizes, so it's currently not the right method to use when developing anything large. When I designed and built this prototype kitchen, for speed and cost, for me, a pine shell covered with MDF and plastic tubing was the obvious choice. As much as possible, always make everything actual size. You can't interact with a scale model in the same way. I could have saved time and materials and money making a scale model of my kitchen, but it wouldn't have highlighted any problems in use or told me half of the things I needed to know. Often the first prototypes you make are made as quickly as possible to determine if you can carry on down one avenue of exploration or identify that it's a dead end and move on. Look at this chopping board. There's no point in spending a day making a full prototype like this when 5 minutes experimenting with paper or cardboard will tell me if the mechanism works or not. Time is money, so wherever possible, prototype fast and prototype cheaply. Don't underestimate how many questions you can answer quickly with card and sellotape and pieces of rubbish. I used card and sellotape for my first wheelbarrow prototype. Plastic bottles to work out weight distribution for a vacuum cleaner, which wasn't testing a mechanism, but prototyping user interaction to work out how acceptable or feasible a new method of doing something would be. And never forget Lego. So you don't need a lot of tools and materials to prototype.